All right, welcome back. I know that was kind of abrupt ending to that other video. I only have 15 total minutes per video that I make on this free app deal. If you have any better suggestions of screen recording software, please email those to me and maybe I can implement that. For now, again, doing the best I can. I get 15 minutes total. So let's continue this part 2 of our Unit 6 notes. We're working on the Pythagorean Theorem, a squared plus b squared equals c squared. So again, yeah, let's continue that. Let's get through this fast. Remember, in this example, we are finding the area of each figure. So essentially, we need to use Pythagorean theorem to find a missing side, and then we will use what we find through that, calculate the area. Just a reminder, area of, or I guess I'll write it this way, area of a triangle is going to equal 1/2 base times height. So we need to know about the base and the height. Now, a couple problems ago, we talked about a height of an isosceles triangle, right? And it was that imaginary vertical line we drew from the tip of a triangle down to the center of the opposite base. And so that's exactly what we have here, actually. This line that I'll highlight in green is our height. We just turned our triangle to the side. And so it creates a 90-degree angle with that middle side, or that side opposite from it. And it also cuts that side in half. So that 10 feet is now 2 sections of 5. And that's crucial because I'm going to call our green line our height x. And when we put it in there, we get a right triangle, which means we can use a squared plus b squared equals c squared to solve for the missing side. And that, in this case, will be x. So again, we're going to kind of just focus on this smaller triangle on the bottom. The reason is we need a right triangle to do the Pythagorean theorem, and that's where our right triangle comes from. And so that's sides of 5, side of 13, and our x. And that's going to be our height, right, in our equation up here. So let's find x, and then we can put it into the area formula. Remember, look for your 90-degree angle. Across from it is always c. And so our setup for the Pythagorean theorem here is going to be x squared plus 5 squared equals 13 squared. Solve that real quick. X squared plus 25 equals 169. Subtract 25 from both sides. X squared is going to equal 144. And then we take the square root of both sides and we get that x is 12, right? Again, that's what x is, which is essentially the height of the triangle. And so now we need to plug it into our formula to find the area. So area is going to equal 1/2 base times height. So area is going to equal 1/2. And then again, our height is our x. So that's what 12 is. But now we need to know what to put in for our base. So our height cut our base in half, right? Into 2 sections of 5. So do we use the 5 or do we go back and use the 10? And I'm here to tell you that we want to go back and use the 10 because we want to find the area of the original triangle. The original triangle has a base of 10. We cut it in half to be able to find the height, which was x, but we have to go back to the original. Again, that base is 10 when we want to find the area of the original triangle. And so our base will be 10. Our height, again, is what x is. So we found that to be 12. And so our area will be 1/2 times 10 times 12. And so if you do all that in your calculator, you should be getting 60. Units are feet, and they're square units, so that is 60 feet squared. All right, moving on. A couple more problems, and we're done with part 2. So we need to find the area of an equilateral triangle, and all we're given is the perimeter. So let's draw an equilateral triangle real quick. Right here. Equilateral triangle means all 3 sides are the same. And the perimeter is all 3 sides added together. So perimeter equals 60. If all 3 sides have to be the same, then a side is going to equal 60 divided by 3 in this case, which means all 3 sides are 20. So let's put those around the outside. 20. Now we need area. So again, we want 1/2 base times height, right? And so we have a base. We can call it 20. But our height is that imaginary line we can draw that creates a right angle. Call it h this time. We need to figure out that before we can figure out the area. So let's focus on, this time I'm going to do it a little different. this orange triangle here. And let's use a squared plus b squared equals c squared to figure out what h is. Just remember, across from 90 is always c, so 20 is c. Now, also remember, when we drop that height, it cuts our bottom base in half, so 10 and 10. And so again, we're only going to work with the orange triangle, and so that'll give us h squared plus 10 squared equals 20 squared. Solve that, h squared plus 100 equals 400. Subtract 100 from both sides, h squared equals 300. And then we're going to take the square root. When we square root that, we get h equals 17.3. Now, that's our height. Again, just like the last problem where we want to find the area, and we use the full 10 for our base, we're going to want to do that again. Remember, our 20 got cut in half, but the 20 is the original base. We're going to use that for our area. And so the area of this triangle is going to be 1/2 our base, which is our original base, which is 20, times our height, which we just solved for, which is 17.3. Type that into your calculator, and you should be getting 173.2. This time, units are in the word problem. That is inches squared. And there's our area. All right, let's keep going. 50-inch television means that the measure along the diagonal is 50 inches. If the screen is square, what are the dimensions of the length and width? So let's just draw a square. That'll be like our television, right? Here's our square. All the sides are the same length. I'll put the congruent tick marks in there. Now, what the 50-inch means is that if we connect opposite corner to opposite corner, that's called a diagonal. That's what is 50 inches. Now, remember, when you're working with a square, all corners of a square are 90 degrees. And that's important because if we just kind of like isolate this side, here is a right triangle we can redraw, right? And here's a 90-degree angle. Our diagonal is 50. And then both of our sides, our legs, they're both, I'm going to call them both x. The reason I can call them the same thing is because it's a square, right? Length and width are the same in a square. All four sides are the same. And so this problem is going to feel a little bit different. This is still Pythagorean theorem. Let's find our 90. Let's decide what c is, which makes the two x's, a and b. So we're going to get x squared plus x squared equals 50 squared. And now, interestingly enough, we can still solve this because all we have is x as a variable, and we can still get that by itself. 1x squared plus another 1x squared is going to give us 2x squared on this side. And that'll equal 50 squared, and 50 squared is 2,500. Now, we need x squared by itself. Right now, it's 2x squared, so let's divide both sides by 2. That gives us x squared equals 1,250. And then, like normal, we will square root both sides to figure out what x is. So x is just going to be the square root of 1,250, and that is 35.4. Now, recognize the units, that is inches. And then let's readdress the problem. It says, what are the dimensions of the length and width? So we can call one of these length, which is x, and width, which is x. And since they're the same because it's a square, we have the answer. Our answer is 35.4, and that accounts for both length and width. All right. Last problem of part 2, here we go. You place a 16-foot ladder against a wall, and the base of the ladder is 6 feet from the wall. So even before I read too much more, I'm going to start drawing that picture. I am an artist, so here we go. This is my brick wall. I guess it doesn't say brick, but that's just kind of how I view it. There's my brick wall, and it's beautiful, right? And then we're going to lean a 16-foot ladder on that. And so here's my ladder, and that thing is 16 feet. And it says, and the base of the ladder is 6 feet from the wall. And so if I draw a line from the bottom of the wall to where my ladder is hitting the ground, that is 6 feet. Also, the ground and that wall make a 90-degree angle. And so the question is, if you need to reach a window on your house that is 15 feet up, so maybe our window is somewhere up here, is our ladder long enough or not? And so really we need to figure out how high this is reaching. We're going to call it X, and we'll compare it. If it's bigger than 15 feet, we can reach the window. If it's smaller, we can't reach the window. And so let's do this. Again, find your 90, go across from it. That's our hypotenuse. That'll be C. And so 16C this time. So X squared plus 6 squared equals 16 squared. Let's solve this. X squared plus 36 equals 256. Subtract 36 from both sides. So X squared is going to equal 220. And then we will take the square root of both of those, telling us that X equals 14.8. And that'll be feet. So the question is this ladder long enough to reach a window that's 15 feet up? Well, 14.8 is less than 15 feet. So not long enough. And that's our final answer. And that's it. That concludes the Pythagorean Theorem session in part 2 of our notes. And so I hope this helped. Definitely check out, work through some of the problems in the part 2 worksheet. Definitely check out the part 2 homework review video. Thank you for working hard. Have a great day.